Good morning, one and all. My name is Ken Kilcha from number 20951A04A8 of ECB. Today, my chemistry concept video topic is electrochemical cell. So, let us know what is electrochemical cell. Electrochemical cell or active series. When the electrodes, metals and non-metals, in contact with their ions are arranged on the basis of values of their standard reduction potentials or standard oxidation potentials, the resulting series is called the electrochemical or electromotive or active series of the elements. By measuring the potential of various electrodes versus standard hydrogen electrode, a series of standard electrode potential has been established. By international convention, the standard potentials of electrodes are tabulated for reduction half reaction, indication the tendencies of the electrodes to behave as cathodes towards SHE, standard hydrogen electrode, and electrodes with positive E0 values for reducing half reaction do in fact act as cathodes versus standard hydrogen electrode, while those with negative E0 values of reduction half reactions behave instead as anode versus standard hydrogen electrode. The electrochemical series is shown in the following table. A cell's standard state potential is the potential of the cell under standard state conditions, which is approximately with concentrations of 1 mole per 1 liter and pressure of 1 atmospheric at 25 degrees Celsius. Standard aqueous electrode potentials at 25 degrees. The electrochemical series. Elements, electrode reactions, reduction, standard electrode potential, lithium, Li plus E minus, lithium, standard electrode reduction potential is minus 3.05, K, potassium, K plus E minus, K, standard electrode reduction potential minus 2.925, Ca plus 2 electrons, Na plus electrons, Mg plus 2 electrons, Al plus 3 electrons, Zn plus 2 electrons. Their values are standard electrode reduction potentials at volts. Fe plus 2 electrons, Cd plus 2 electrons, Ni plus 2 electrons, Sn plus 2 electrons, H2. 2H2 plus 2 electrons give rise to H2, where the standard electron reduction potential is 0. Cu plus 2 electrons, Cu plus 0.337, where the reduction potential becomes positive. I2, Ag, He, Br plus 2, Cl plus 2, Au and F2 all are the standard electrode reduction potential positive values in volts. The negative sign of standard reduction potential indicates that an electrode when joined with SHE acts as anode and oxidation occurs on this electrode. For example, standard reduction potential of zinc is minus 0.76 volts. When zinc electrode is joined with SHM, it acts as anode, negative electrode, i.e. oxidation occurs on this electrode. Similarly, the positive sign of standard reduction potential indicates that the electrode when joined with SHE acts as cathode and reduction occurs on this electrode. Characteristics of electrochemical series. The substances which are stronger reducing agents than hydrogen are placed above hydrogen in the series and have negative values of standard reduction potentials. All these substances which have positive values of reduction potential are traced below. Hydrogen in the series are weaker reducing agents than hydrogen. The substances which are stronger oxidizing agents than H ions are placed between hydrogen in the series. The metals on the top having high negative values of standard reduction potentials have the tendency to lose electrons readily. These are active metals. The non-metal on the bottom having high positive values of standard reduction potentials have the tendency to accept electrons readily. These are active nonmetals. Application of electrochemical series. Reactivity of metals. The activity of the metal depends on its tendency to lose electrons or electrons, i.e. tendency to form cation. This tendency depends on the magnitude of standard reduction potential. First point, the chemical reaction of metal decreases from top to bottom in the series. Second point, metals like Fe, Pb, SnCi, NiCO, etc., which lie a little down in the series, do not react with cold water but react with steam to evolve hydrogen. Metals like Cu, Ag, and Au, which lie between hydrogen, are less reactive and do not evolve hydrogen from water. Electropositive character of metals. The electropositive characters also depend on the tendency to lose electron or electrons. Like reactivity, the electropositive character of metal decreases from top to bottom in the electrochemical series. On the basis of standard reduction potential values, metals are divided into three groups. First one, strongly electropositive metal. Second one, moderately electropositive metal. Third one, weakly electropositive metal. Third one, to predict whether a given metal will display another from its salt solution. A metal higher in the series will display the metal from its solution which is lower in the series. I.e. the metal having low standard reduction potential will display the metal from its salts solution which has a higher value of standard reduction potential. A metal higher in the series has greater tendency to provide electrons to the cations of metal to be precipitated. First one, displacement of one non-metal from its salt solution by another non-metal. Oxidation half reaction. 2i minus gives rise to I2 plus 2 electrons. Reduction half reaction. O2 Cl plus 2e minus gives rise to 2Cl minus electrons. Cell reaction Cl2 plus 2Ki gives rise to 2KCl plus I2. The activity of electronegativity, negative character or oxidizing nature of the non-metal increases as the value of reduction potential increases. Displacement of hydrogen from dilute acids by metal. Oxidation half reaction, reduction half reaction. Mn gives rise to Mn plus Ne minus. Reduction half reaction 2H plus 2 electrons gives rise to H2. The metal which are below hydrogen in electrochemical series like Cu, Hg, Au, Pt, etc. do not evolve hydrogen from dilute acids. Displacement of hydrogen from water. The tendency decreases from top to bottom in electrochemical series. Alkali and alkaline earth metal liberates hydrogen from cold water, but Mg, Zn, Fe federate hydrogen from hot water or steam. Reduction power of metal. Reducing nature decreases from top to bottom in electrochemical series. Sodium is a stronger reduction agent than zinc, and zinc is stronger reduction agent than iron. Alkali and alkaline earth metals are stronger reduction agent. Oxidizing nature of nonmetals. Oxidizing nature increases from top to bottom in electrochemical series. The strength of an oxidizing agent increases as the value of reduction potential series The strength of an oxidizing agent increases as the value of reduction potential becomes more and more positive. F2 fluorine is a stronger oxidant than C12, Br2 and I2. C12 chlorine is a stronger oxidant than Br2 and I2. Products of electrolysis. In general, in such competition, the ion which is stronger oxidizing agent, high value of standard reduction potential, is discharged first at the cathode. The increasing order of deposition of few cations is K plus, Ca plus 2, Na plus, Mg plus 2, Al plus 3, Zn plus 2, Fe plus 2, Cu plus 2, Ag plus, N plus 3. The increasing order of discharge of few anions is SO4 minus 2, NO3 minus, OH minus, Cl minus, Br minus, I minus. Thus, when an aqueous solution of NaCl contains Na plus, Cl minus, H plus and OH ions is electrolyzed, H plus ions are discharged at cathode and Cl minus ions at anode. H2 is liberated at cathode and H plus ions are discharged at cathode and chlorine at anode. When an aqueous solution of CuSO4 contains Cu plus 2, H plus and OH minus ions is electrolyzed, Cu plus 2 ions are discharged at cathode and OH minus ions at anode. Where cathode reaction will be Cu plus 2 electrons gives rise to Cu, and anodic reaction will be 4OH minus gives rise to O2 plus 2 H2O plus 4E. Cu is deposited on cathode while O2 is liberated at anode. Thank you.